Welcome to this recording on the WellCAD ISI module. ISI stands for Image and Structure Interpretation. We start the ISI workspace by clicking on the ISI button in the toolbar. We open a new workspace and we need to select the log that we want to work on. In this case, the amplitude log. WellCAD can handle optical image logs, acoustic image logs, and also micro-resistivity logs. We need to enter the caliper data. It can be a fixed number, for example, bit size, 96 millimeters, or it can be a caliper log. The units we work with can be millimeters or inches. The depth of investigation is only relevant in the micro-resistivity logs. ISI can calculate from apparent dip to true dip, taking into account the borehole deviation. In this case, we use the azimuth and tilt logs. WellCAD can also recalculate from magnetic north to geographic north if you know the rotation angle. WellCAD can also display as a first track in the navigation bar of the workspace an extra channel. In this case, the image complexity map, which displays the complexity of the image. You can see on the left-hand side, we have a navigation bar. One can right-click and zoom out to, let's say, a 1 in 500 scale. And you can have a nice overview of the borehole here. If we right-click and then zoom into, let's say, a 1 in 100 scale, you can see the blue area is displayed in the main area of the workspace. If you scroll down, you can see that the blue area is moving as well. In the navigation bar, we can define some zonations. You activate the Add Zone function, and then you click to put on the first boundary just below the casing, and then a few more just around this complex area. We can now do the interpretation on a zonation by zonation basis. In the ISI workspace, we don't need the confidence level as it is related to the auto picking, which we are not covering here. So we switched its display off. What we also want to do is to add normalized amplitude from the main document. So we select the normalized amplitude by clicking on the mouse button and dragging it over to the workspace. Then we can do some rearrangement of the data and we can select the amplitude and the normalized amplitude using the control key, and we display them next to each other and making them the same width. Before we do the picking, we need to add a classification. So in process, we select classification tab and we click on the plus button to add a classification, and we can load the default classification that comes with the WellCAD name fracture ranking. We can edit or create our own dictionary or classification, or we can select a predefined one, in this case called pick type. The classification is now being displayed. There are actually some options here in the classification. If you go to the settings using last, your pick will be the same as the previous pick. It can also be unclassified, or it can be user classified. If, let's say, most of your picks are natural joints, you select natural joints as the default. In this case, I will keep it unclassified. How do we do the picking? The way you do the picking is to press the Shift key, and you keep the Shift key down and click a couple of times on the senoid until it fits nicely. Then you can see the senoid being drawn and the tadpole being displayed, and also the structure in 3D. One more time, you click on the Shift key and click a few times on the senoid until it fits perfectly. If the senoid doesn't fit correctly, you press the Control key to delete it, and you can draw the senoid again. If you think the picks are not clear to see, you can go to the properties. You can increase the pen width to a thicker line. We do a few more picks. You can right-click and zoom in if you need, and then we do more picks. You can also do the picking in the normalized image, and it doesn't matter. You can use either one. How do we assign classification? If you select the pick, which is in this case highlighted in blue, you click here on the attribute and you assign the classification. ISI also allows you to display stereonets. If you look at the stereonet, you can see all the pics are being displayed here in the stereonet with the colors of the classification. Another way to assign classification is to press the Shift key and do a bit of clustering in the stereonet. You select some of the pics and then click on the classification and you can assign a classification. In this case, I call them fault. And last but not least, you can also use the Shift key. You can select a range in the tadpole log and assign a classification from there. If you go back to the stereonet also allows you to display apparent dips or true dips. It also allows you to display the wolf net or the Schmidt net. You could toggle between polar grid and equatorial grid, and between northern hemisphere and southern hemisphere. You can also display great circles if you want. ISI can also display the rows diagram, as you can see here. Let's assign a few different classes. Press the Shift key, assign them as faults. Then in the rows diagram you can see they're being displayed as faults. And also the rows diagram allows for different display options. When you go down a bit, you can see that there's an open fracture, and ISI will handle open fractures. Press a Shift key to draw the senoid, and when it fits nicely, press Shift and Control key together. You will get a double arrow and you can open the fracture like this. Press Shift and Control key to open it more. This is how WellCAD can handle open fractures. When we go down a bit further, you can see around 239 meters we have a partial fracture. So when we press the Shift key to pick the full fracture, and then you can actually zoom to a 1:5 scale and see more details. And now I will interpret the partial fracture. What we do is to first click on this partial sinusoid until it fits nicely. And now you can see we have two structures. When pressing the P for partial pick, you see that there is a dashed line. So you can click on the starting point and then click on the end point, and WellCAD will display it as a partial pick. When pressing the P again, you can move the starting point and the end point around until it fits nicely. This is how it looks like now. When you go to the table editor, by right-clicking on the apparent pics, you can see the depth of the senoids being displayed in this depth column. The amplitude and the dip is displayed in these columns. The structural types are on the right-hand side, and the aperture is recorded, in this case, in millimeters. The partial pics are also picked in this column, and the range is from 27 degrees to 129 degrees. On the left-hand side, you can see the feature depth, which is the depth of the partial pics, while the depth column itself displays the depth of the full senoids. When you finish picking, you can copy all the data to the main document. Because there's no interactive link between the main document and ISI workspace, you can see it here. So we go back to the ISI module, click on the export log icon, and you typically export the apparent pics and the tadpoles to the main document. Click on OK and close ISI module. Now you can see that they are being displayed here in the main document. Typically you display the apparent pics on the top of the image log and tadpoles next to it. When you zoom out, this is how the data looks like. We want to show one more thing which is not part of ISI, but is a nice feature. Click on the Edit button, go to Insert a new generic log, and insert a 3D log. Display the 3D log right next to the amplitudes, giving it a proper name. You can put in a caliper component, and in this case from the caliper curve. Put in the amplitude component and put in the structured component. And this is what we wanted to show you about the ISI module. Thank you for your attention, and we hope to see you in the next video.